Welcome to byIITians. In this class, I will discuss the building materials previous year question asked in TNPSC AE and SSC JE. For Portland cement of 43 grade, 20-day mean compressive strength should exceed 43 megapascal, 43.5 megapascal, 33 megapascal, and 38.5 megapascal. So here they are asked for what is the minimum compressive strength of the cement of grade 43. Okay. So we know that for 43 grade of cement, the minimum value will be 43 megapascal. It's nothing but 43 Newton per millimeter square. Okay. So megapascal can be written as Newton per millimeter square. So we know that there are three grades of concrete. One is 33 grade, 43 grade, and 53 grade of cement. So these grades are differentiated with the compressive strength, right? So this compressive strength for 33 grade of cement will be having 33 Newton per millimeter square. For 43 will be having 43 Newton per millimeter square. Similarly for 53 also. Okay. Now I would like to discuss some of the other physical properties of the cement and their methods with respect to the three grades of the cement. So the other thing are fineness, soundness, setting time, and compressive strength, and their method of testing. So what will be their value with respect to the 33 grade of cement and 43 grade of cement and 53 grade of cement. The first one is fineness. It is measured with the help of Blaney's air permissibility. So for 33 grade of cement, it will be having 225. For 43, it will be having same value 225 meter square per kg. It is nothing but the specific surface area. So which means if you take 1 kg of any the cement, like any grade 33 or 43 53, and spread it over area of 2 area in meter square. Okay, so which means here the value 225 indicates if you take 1 kg of cement and spread it over area of 225 meter square. That is the concept behind this. Okay, next one is soundness. So soundness will be measured with the help of leach apparatus. For this 33 will be having limit of 10 millimeter, so that is the maximum value. It should not exceed that. For all this grade, it is similar value. For autoclave test, we have to remember this 0.8 percentage. All these cements will be having the same value. Now the thing is setting time. Okay, setting time will be having two things. One is initial setting time and another is final setting time. They are asked for in minutes. It is find with the help of Vicat apparatus. Okay, the initial setting time will be for all the cement is 30 minutes only, and final setting time will be 600 minutes, which means 10 hours. That we have to remember. So for compressive strength, we'll be checking after 28 days actually. So it sometimes we'll be checking also for 3 days and 7 days. So at 3 days, the value for compressive strength is 16 for 33 grade, 23 and 27. For 7 days, it will be 22, 33 and 37. After 28 days, these grades will be having these values 33, 43 and 53. All these values are in megapascal, which means Newton per millimeter square. So these are the properties of this grade of the cement. So now I'll move on to the next question. In a slump test, each layer of concrete is completed by a steel rod 60 cm long and 16 mm diameter for 20 times, 25, 30 and 40 times. So here they are discussed about the slump test. So slump test comes under the workability test. Okay, so first I will discuss what is workability. It is nothing but the how much easier to work with the concrete, which means indirectly it determines the how much water is added to the concrete. Okay, so workability of concrete is measured with the help of 5 methods. First one is slump cone test. Next one is compaction factor test. Third one is VB test. Fourth one is flow test, and last one is Kelly ball test. So these are the 5 tests used to measure the workability of concrete. So indirectly it shows the how much water is added to the concrete. Okay, so here they are asked for slump cone test. So first for that I will discuss the procedure of slump cone test. So in this picture, this is a slump cone plan, and this is the elevation which is used to find the workability of the concrete. So the top dia of this cone is 100 millimeter. All the dimensions are in the millimeter. We will be having 2 handles here to lift this cone, and the bottom diameter will be having 200 millimeter, and height of the cone is 300 millimeter. Okay, this is how it looks. The procedure for this is, first we have to make the concrete as per the proportion. Okay, as per the grade of the concrete we'll make the concrete, and here we have to fill the concrete for 1/3 of the cone. Okay, this is the first layer. So after filling the first layer, we have to take the rod of 60 centimeter long and 16 millimeter dia, and we have to go for the compaction of 25 times. We have to 25 times compaction we have to do, and after that we have to go for the second layer. So second layer, the next 1/3 of the cone is filled and compacted for again 25 times. Similarly we have to do it for the last layer also, third layer. So after doing this, we have to remove the excess concrete which is in the top of the cone, and in the fifth step we have to slowly remove the cone in the upright position. Okay, using the holder. We have to remove it in the upright position. Then the concrete will be settled. Okay, settled. Now we have to measure this value. Okay, how much it is settled. That value is called as slump value. Okay, so this slump value will determine shows that how much water is in the concrete. Okay, it is higher or lesser, it depends on the work. For example, if you're casting a road, we'll be having different slump value. If you're casting a slab, then we'll be having another slump value. So that is having different values. So we'll be having 4 types of shapes. One is true shape, another is zero shape, collapse shape, and shear slump. So true slump is nothing but it resembles the same shape of the cone but decrease in height. Okay, so this is the true slump, and this is zero slump, which means it remains as the shape of the cone. It will not decrease in the height. This is zero slump. And this is collapse slump, which means it will be having more water. In case if you are adding more water, this concrete will not be stiff enough so that it will be fall on the ground. This kind of slump is called as collapse slump, and the part of slump is sheared, then it is called as shear slump. So for this question, we have to compact 25 times each layer. So option B is the right answer.